Here is another problem from the 5th module. Find the effect of coefficient quantization on pole locations of the given IIR system when it is realized in cascade form. Assume a wavelength of 3 bits excluding sign bit. And the scheme of valuation are obtain the cascade transfer function 2 marks, then truncation of coefficients 3 into 2 marks, and finding h of z 2 marks. So it's a 10 marks question. Actually it is a simple question. Now let us solve this problem. So given h of z equal to this value and the wavelength equal to 3 bit excluding the sign bit. The first step is the determination of the cascade structure for this system function, which can be easily done by factorizing the denominator. The denominator can be factorized. The fact is we can easily get using a calculator, so that you will get 0.5 and 0.3. Then the corresponding factors are 1 minus 0.5 z inverse and 1 minus 0.3 is z inverse. So here decompose the denominator into this form. Now which is equal to h1 of z and h2 of s. h1 of z, this one h2 of z equal to this one. So the first part is over, that is expressing h of z in terms of cascade structure. Next we have to determine the poles. Now the poles can be obtained as 1 minus 0.5 z inverse equal to 0, from which z equal to 0.5 and z equal to 0.3. So the poles are located at z equal to 0.5 and z equal to 0.3. Now we can convert this poles into binary form and quantize it to 3 bits. Now we can convert these poles into binary form, so that 0.5 equal to 0.1 and 0.3 equal to 0.01001, etc. So this conversion of 0.3 to binary format is shown here by the continuous multiplication by 2 method. Next we have to quantize the binary to 3 bits. So the first bit is for the sign bit. Since 0.5 is positive, we can say the bit is 0 and the remaining 3 bits for the data. So 0.1 can be represented as 0.110 in binary, whereas 0.3 is quantized. That is, the fourth bit here is 0, so that up from fourth bit onwards we can simply discard, so that the value become 0.010 binary format. Now convert this quantized value into the decimal. So after quantization the poles become 0.101 equal to 0.5 itself, whereas 0.10 this is 0.25. Now the corresponding h of z after quantization obtained as 1 minus 0.5 z inverse into 1 minus 0.25 z inverse. So the pole at z equal to 0.5 retains, whereas the pole at 0.3 shifted to 0.25. So this is our final answer. Now the problem is solved. Thank you.